Welcome to Ask and Learn.
In this problem, we're given the equation for the height of the ball, and we want to find its maximum height. There are two different ways we could do this. The first is sort of the algebra way, so we would recognize that this height equation is that of a parabola, and it would be a parabola that opens down, and if we could find its vertex, we would know the maximum. The other way to do it is to use calculus and to realize that when it's at its maximum, the derivative will be 0, and so that's when the velocity is 0. And my vote is to use calculus for this problem because we are in a calculus class. So we're going to find where the time that the velocity is 0. So we need to find the velocity. So we take the derivative of position and we get 80 minus 32t. And then we're going to see when that equals 0. So we set it equal to 0. I keep wanting to say where it equals 0, but it's when it equals 0. Solve this for t, and we end up with t is 2.5 seconds. So now we want to find the height at 2.5 seconds. So now we go back to our height equation and substitute a 2.5 in there. And we get 100 feet. And for part B, we want to know the velocity when the height is 96 feet. And the height is 96 feet in two different times, once when it's on its way up and once when it's on its way down. So the first thing we need to do is find the times that it has a height of 96 feet. So what we can do is take our height equation and set it equal to 96. So we have 96 equals 80t minus 16t squared. Let's get all the terms over to one side. So 16t squared minus 80t plus 96 equals 0. And then the whole equation is divisible by 16. So we have t squared minus 5t plus 6 equals 0. And luckily that's factorable. This is our lucky day. We can factor it into t minus 3 times t minus 2. And then set each of those factors equal to 0, and we get the 2 times 3 seconds and 2 seconds. Notice how those are symmetrical about the time when it was at the top. It was at the top at time 2.5. So this all makes sense coming together. So now that we know the times, we want the velocities at those times. So the velocity at time 2 would be 80 minus 32 times 2. And that is 16 feet per second. And that's when it's on its way up. And then the velocity at time 3 would be 80 minus 32 times 3. And that is negative 16 feet per second. And that is on its way down.